Hi, my name is Ray. I'm with MEMETechnologies, and I want to do a quick video on how I model threads on Inventor. And this can basically be translated over to any other, software like Autodesk Inventor, like SolidWorks, NX. Those are the only ones that really come to mind that I remember. I don't even know the name of the NX one, but it's called NX something. I forgot, Siemens or something like that. Anyways, I want to show a quick part. Probably already seen it on my channel. If not, this screw rod I designed for 9-inch mill vise. And on this screw rod, we have two basically different threads. One is a 60-degree regular coarse thread, and the other one is an ACME thread. It has a different angle on there. Excuse me. And what I'm gonna do is I'm basically gonna choose two threads from that are 60 degrees and two threads that are ACME, and I'm gonna model them just to show you how I model them, just so I can give a reference of how I do it. And I'm not sure if in this video or maybe next video, because I haven't modeled one in a while, sufficiently enough that I can't really remember how I did it. I mean, I know it's easy, I'm pretty sure, but I just don't want to be pausing too much because I don't generally edit the videos. I just do it in like one take, no script, or sometimes I have talking points, but in this case I have no script, no talking points, no nothing. So I'm hoping I can do this in this is like my second or third take. So yeah, so like I said, we're gonna pick two threads that are 60 degrees, two threads that are ACME, and eventually we'll pick two threads that are 60 degrees, but they're for pipe threads, NPT threads. They have the angle. I forgot what angle it is, like 1 point something degrees, 1.7 degrees, something like that. But yeah. So let's go over here real quick. This is you can pretty much see what I looked up, Machinist Handbook thread chart. And just for reference, just so everyone knows, I have my own copy. I bought it from Amazon I don't know, a couple years ago. It's like the big one with the thick hardcover. It looks like a Bible. It has like the little sections and stuff too. Like, it's pretty nice. And it came with like two other books, I think, or I don't know if it's just one other book or two other little books. And yeah, I have them around here somewhere in the shop, but probably in my toolbox or probably over me on my desk or some shit. But yeah, so everyone knows, I already bought this. I have this purchase book or whatever. I also have a gauge maker. We also bought that too. So but I'm not gonna look at that. I'd rather just look at the book, something that everyone can access, because not many people have the money, or not many people want to pirate or something if they don't have the money. Someone would probably pirate or something. It's probably not a good idea. But some people don't have I forgot how much it costed. I think it was like $600-$700 or something. But I'd rather just show the book. That way we can go through it a little bit, not completely, but just lightly go through some of these things. To be honest, I'm probably not even gonna go through it. I'm just gonna summarize what we need and then just go through it. I think someone better versed, better good at talking, better someone with a script or some shit. Excuse me, someone who doesn't burp every 5 fucking minutes. I think that would be a better person to be able to, someone with good words, doesn't pause every second and says But anyways, we are gonna summarize this, and you can pretty much see where I'm at right now. I'm in the unified screw threads, one of the few first pages. Once you get to the threads section of the book, Or if you want, you can just do Control F. I think that's what it is, and you can just find it. And right here, what we're gonna do is we're just gonna look at this. This is basically what we need. We only need a couple of pieces of information. We need what the H. You look at this, right? We have the H. The H is the height of the sharp V thread. So that's what we're gonna need, the height of the sharp V thread. And the next thing we need is the pitch. The pitch line is this one that's going all the way through. Please excuse my giant mouse. I am pretty blind. Well, not really blind, but borderline. I like to use, you know, big mouse pointer things. That way I can see easily. Because I have a really big monitor. Even though I squeeze it down to 2560 by 1440 just so I can record the video. But anyways, I go on tangents a lot. So we need the, like I said, the H, which is the height sharp V thread, and we need the pitch line, which is right here. And we'll, from looking at this, we can assess. Let me zoom in a little bit more. We go right here. If you add 0.375 plus 0.125, you should already know this, but it's sort of half inch, 0.5. And if you add 0.25 plus 0.25, you get 0.5. So right here you have 0.5. Right here you have 0.5. What H is the pitch. I honestly, I don't even know what I'm saying. But basically the pitch line is basically halfway point. That's basically what it means. I want to say, that's what I'm saying. I don't even know where I'm going with this. But the pitch line, this line going through the middle, is basically the midpoint. So that's basically the only reference that we need. And halfway up is this point, and halfway down is this point. You know, from here to here, you get 0.5, and then from here to here, you get 0.5. It's the same thing up and down. So now that we've established these things, well, we should probably just draw it out real quick so we can delete all the stuff that we don't need, because look at all this stuff. And you know, it's all useful information, but it's just to model it. We don't really need it, because we just need it to look sort of good. Later on, we could probably come back and give it the I think, what are these called? Some of them are roots, some of them are flanks, some of them, no, the flanks are these, I believe. Right. What are these? Hold on. Oh yeah, this is the crest. Okay, crest. This is the root, and these are the flanks. The lines, the 60-degree lines, or well, 30 degrees, depending on how you look at it, are flanks. But anyways, that's about as much as I'm gonna go in it. So the first thing that we're actually gonna use is called the snipping tool. Click new. I'm gonna take a picture of the whole page. Gonna do edit in paint, and we're gonna delete everything actually. And actually, do we delete everything? No, we don't delete everything. We're just gonna delete what we do not need. So all of this, delete, 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 delete. And I believe that's it. I don't think we need all this either. So this is all we really need. Dang it. What the fuck? Oh my god, why? Okay, whatever. Oh, I forgot, because the monitor goes up or whatever. I don't really need it. It doesn't really matter. Okay. So the next thing that we're gonna do, so we got that. We're just gonna mark it real quick with red, just so everything is clear. Do a red line, and this is the pitch line. All right, pitch line, let's name that. I wonder if it'll do it. Nice, it's red, pitch line. Let's also make the background red to really solidify that this is red, but no, I'm just playing. So the red is the pitch line. I probably should make that bigger. I wonder if I can do some black magic. Hold on. Ooh, yes, sir. All right. Pitch line. There we go. We got the pitch line. And let's let's do some, well, we don't need to do any math, we just need to give it a thing. Let's do, how would we describe this in another way? Because I know it's half and half, so let's do the math real quick, just so we're clear on that. 0.125 plus 0.375 equals 0.5, and let's do the other one real quick. Is 0.25 plus 0.25, enter, equals 0.5. So we got 0.5 and 0.5. So let's do the top and then the bottom, different color. Okay, so let's do something like blue for the top, and it's 0.5. Let's make this big as fuck. This down real quick. 0.5. Then we also got, so make this one purple. 0.5. And I'm just gonna move a little bit over here, make it a little bit bigger. Do the same thing over here, make it a little bit bigger. Oh shit. Alright, so we got 0.5. And now let's do the lines. Do the purple one. Let's do it right here. Okay. Okay, looks okay. And then let's do the blue. I believe it's this one. Okay, looks all right. Nice, okay. And let's make the H, I guess, green. Oh shit, is this blue? Why is this blue? There we go. Now, the other one, let's make it green, I guess. We're gonna go right here. I don't even know if it's gonna fit. I'm pretty sure everyone understands what I'm trying to say by this. Okay, there we go. Now I'll just put it like this. Probably should have established that a while back. I'll just delete it. Oh. I really need a way to edit these videos. Alright, the H, and now H. Alright. Yeah, basically that's all we need. We just need a pitch line. Alright, I guess let me rename this real quick. I don't know which one's red now. Pitch line. Pitch diameter. Alright, I forgot to mention that pitch line is just the pitch diameter. We're gonna get into that anyways in a bit. So now let's go to the threads actually. Unzoom out of this real quick. Alright. Actually right here we're gonna look at this table first, because this is one of the tables we're gonna come back to more. I dropped my phone. More frequently than anything. This is basically the reference that we're gonna get for the depth of sharp V thread. That's the H that we need. And it even says right there it's 0.86603 from the pitch. And it says right here 0.86603 from the pitch. So this is the main thing that we're gonna come back and look into. For example, if we're gonna do a off the top of my head, a 5/8 by 11 NC thread, We're gonna go to the threads per inch because it's gonna be 11. I jumbled up my words, my apologies. Threads per inch is 11 because 5/8 is the diameter, 11 is the pitch, threads per inch. So 11 threads per inch, 11 TPI. And we're gonna go to the depth sharp B thread of 11 threads per inch, and that's basically what we would use after we would get the pitch diameter. And I think it's actually, no, it's not here. It's probably not here. See, I don't even know my way around the book. That's why I'm not trying to show the book off, and try to explain it. I'm just gonna show you what a little bit that I know, my little slice or whatever. Yeah, so none of these talk about pitch diameter, so we're gonna go down to the thread. For example, let's just do a 5/8 by 11. Let's write that down real quick. So we're gonna get the 0.07873 is the H. 0.07873. Okay, so we're gonna do a thread, and each thread is gonna be, let's make them black. Okay, so it's 5/8 inch. Whoops, wrong button. Dash 11 and C. And for the other thread, off the top of my head, let's do a 2x4 or something like that. 2 inch by 4. And instead of doing NC, I'm just gonna put TPI because I'm not sure what the standard is on the chart. Some of them are just threads, some of them are NC, some of them are NF, some of them, I think that's it. I'm not sure. Anything else would be me talking out my ass. So we got 5/8 inch by 11 NC, and then we got 2 inch by 4 TPI. Those are the two main threads we're gonna look at right now. I guess we could look at a fine thread or whatever. So let's pick a fine thread. Let's pick a 7/8 fine thread. 7/8. I don't even know what the fine pitch is for the 7/8, but I'm just gonna do 7/8. I'm just gonna write it out. 7/8 fine. That's because that's all the information that we have right now. So think of it as taking notes. We're just gonna go with whatever we have right now. Because like I said, I don't know if this is 4 NC or it might be 3. It might be 2. It might be 4. I don't even know. But it might not even have an NC or an NF or anything. I know it's not NF. I know that's for sure. It's not NF. But anyways, those are the 3 main threads we're going to look at right now. Let me make this a little bit bigger. Let me make this a little bit bigger. Cool. All right, and then let's actually make it a little bit big. Let me separate them actually. We're gonna put this one over here. We're gonna put this one over here. We're gonna put this one over here. So let's go do the 5/8 by 11 and see. Let's actually write down all the information that we're gonna need. So now that we're here, we're gonna write down the information for the 11, for the 4, and we're gonna see what the 7/8. We'll look for it in a bit. We'll leave that one for towards the end. So it's for the 11, it was 0.078 something. I have a bad memory. 0.07873. Okay, 0.07873. So, and the H, let me actually make it like that. H equals fucking mosquito. Did I catch it? No, did I? No, I don't think so. The H equals 0.07873. I believe that was what it was. 0.07873. 0.07873. All right, cool. Now the next one is going to be a 4. So we're going to go to 4 threads per inch right here. 0.21651. 0.21651. Okay. 0.21651. 0.21H equals 0.21651. I think that's what 21651. Where is it? Where is it? Where is it? 21651. 21651. Nice. Okay, we got the H for this one. And now we're gonna look for what actually would be the fine thread for 7/8. So we're gonna go down, down, down. This is yeah, I'm not even gonna attempt to explain anything. We're just gonna look for the thread. I don't want to put on a mask and say that I'm smart enough to explain everything here. So we got 7/8 right here. It's UNF, should be this one, because we have right here 7/8 UNC. So it should be 7/8 14 UNF. So we're gonna go back right here, fine, and then we're gonna put in parentheses 14 and F. And we're not gonna delete anything, just so like basically as a note, so we can know that we didn't know what it was, but now we know what it was, whatever. So now that we have that, we got 14 threads per inch, the NF. So we're gonna actually go back to the book and go back to the other page that we were at. 14 right here, 0.06186, 0.06186. H equals 0.06186. Fat finger that. 0.06186. That's our H for this. Cool. Now the only thing that we need is our pitch diameters. Pitch diameters. So we're going to start with the smallest thread, because those are going to be the ones that show up first. So the smallest thread out of all of these would be the 7/8 by 11 NC. So we're going to go to that one first. We're going to go to the book, 5/8 by 11. 5/8 by 11 NC, and then we're just going to highlight the whole thing. We're not even going to go through the 2A, 3A, anything. Those are just different tolerances and stuff, different fits, I think. I'm not sure. But we're just going to go for the regular one. So I didn't even think about modeling internal or external. Damn. I guess we can do both. Hopefully I don't take too long or make too many mistakes, but let's go ahead. Let's see how deep we can get right now. So first we have let's do an external, and let's do the socket head cap screw for it, and let's do a nut for it. And we'll just go to Granger. They're not paying me or anything to mention them, but that's the website that I use, just so everyone's clear. You can use McMaster, you can use whatever website you want, but I'm gonna use Granger for this because that's usually what I use. That's usually what I buy, because I can just pick up from many different stores here in Houston and stuff. So we're gonna do the first thread. We're gonna do both threads. We're gonna do the 1A and the 1B. We're gonna, and I said all we need is a pitch diameter and the H. No, but we're gonna need diameters and stuff. Major diameters for the external threads, and for the internal we're gonna need the minor diameters, basically the tap drill for the internal. But anyways, let's go for the external. 5/8 by 11 NC. Let's go to Granger real quick. Let's do I'm already always over here, socket head cap screw. Let's do 5/8 by 11 NC. And for the other ones, I think for this one we're gonna do both, but for the other ones, I don't know. I'm just gonna say we're gonna do something. We might even, I don't know. But anyways, let's just do one of these and we'll see how it goes instead of predicting shit that's probably gonna be wrong. I just randomly chose this one, 5/8 by 11 by 2-inch length, and I'm pretty sure it's 5/8 plus 2-inch for the overall length, 1 5/8 probably. But let's look at the drawing, dimensional drawing. We could download it, and this is how you pretty much download. You choose just wait till this loads. Excuse me. And then you choose which one you want. But I'm not gonna download it. I'm just gonna model it, and we're gonna model this one. We're gonna use the dimensions for this one. So this is the thing that we're gonna make, and I believe the way that what do you call it? that these threads are made. These threads are rolled, which is why you see this sort of in the middle. Let me see if I can show it. You can see it's sort of in the middle, because if you go all the way here, you're below it. But if you go out top here, you don't see it. But if you go to the middle, you see that one at the top. Basically in the middle. And basically they use the pitch diameter. They leave it, I think, at well, not maybe not the pitch diameter, but they leave it at a certain diameter to where the thread is actually pressed onto it, rolled onto it. And that's like, I think, the most fastest way to make a thread. Of course, instead of having to put it on the lathe and cut it and stuff, you just make the blank. You have a machine that makes nothing but blanks, and then you stick it in for like a few seconds and it does it. So let's model this real quick. 2" by, yeah, that's like I said, the 2" is just the screw length. Then you have the head length is equal to whatever the thread is. So we got 5/8. 5/8 thread equals 5/8 head thickness, head length, whatever. Then the diameter is 0.938, and the hex is 1/2 inch for, you know, 1/2 inch hex key, hex drive, whatever. And it's 307 thousandths deep, and I'm not sure what angle this is, but I could assume that's 118 or 135. I mean, they're probably not going to use, you know, what we're going to use. They probably have their own proprietary tools. They probably stamp this. They probably just stamp it. I don't know how they do it, to be honest. But I'm sure they make it a simple way, like a way that makes thousands, and like literally what would take us, you know, a long time to do. Like one of them or two of them or whatever. But just mumbling and babbling on about nothing. But let's model this real quick. So let's go back, and we're not gonna be using since we're gonna be technically cutting it, we're not gonna be using this diameter, which is what I assume to be the pitch diameter. For the back, I'm not sure what we're gonna do. Well, we'll probably just leave it at the diameter. We're not even gonna touch it or whatever. We'll just leave it at whatever the major diameter says on the chart. So let's go to this real quick. We're gonna model it two different ways. We're gonna model it extrusion type first, and then I'm gonna model it I'm gonna attempt to model it revolve style, and that's how we're gonna do it. So excuse me, the major diameter is between 6234 and 6052. So what I'm gonna do is I'm just gonna divide those by 2 and then just get the difference or whatever. So we got 0.6234 minus 0.6052, enter. Then you divide it by 2, and then you add that to the minimum. So this plus 0.6052. You got 0.6143 would be the midpoint between these two diameters. Sort of. I'm not sure if that makes sense. But anyways, we got 0.6143. That's what we're going to use as the diameter for it. So let's actually write it down, I guess. Let's go for Mage. Gonna be, what's it, 0.6143? 0.6143. Major D, 0.6143. Major D, 0.6143. And after that, what we're gonna need is the pitch diameter. We're gonna do the same thing here. 0.5644, 0.5644 minus 0.5561. And just for reference, this is the pitch diameter. This is what I'm looking at. 0.5561. Enter. You get 0.083. Then you divide it by 2. Enter. Plus the minimum 0.5561. And this should be between those two. So it should be more than this and less than that. So you got 0.560. It's more than 0.556. It's around 4 thousandths over, which is, yeah, 4 thousandths. But yeah. Anyways, yeah, that should be good. 56025 is our pitch diameter. 56025. 0.56025 P dot D dot is what is it? 0.56025. 0.56025. All right. I think that's it. I'm gonna put, I should probably just put it on the thing, but external thread, whatever. Looks good. Okay, so let's use those dimensions. 0.6143 is the first dimension we're gonna start off with. So let's go to Inventor and let's do new. Let's do standard IPT. Let's do standard 2D sketch, XY plane. Let's do circle. Let's do tab 0, tab 0, tab enter. So it goes all the way into the middle. And then do, I believe it was 0.6143, 0.6143 as the diameter. Let me just verify that. 0.6143, yep, is the major diameter. Go back to Inventor, 3D model extrude. We're gonna extrude it by 2 inches because I believe that's what the thing said. 2 inches. All right, now we need the head. It's 0.938 by 5/8 length. 0.938 diameter by 5/8 length. So let's go back to Inventor. Start 2D sketch. Let's start it where we left off. And then it's gonna be circle. Go to the middle. You can just go to the middle till it turns green as well. That's another different method. Just make sure it's green and it says 0, 0, 0, 0, 0, 0. And left click. And then that's gonna be 0.938. Enter. 3D model extrude. 5/8. 0.625. Enter. And we have sort of a blank. And let's do the hole real quick. I believe that's gonna be 1/2 inch diameter for the hex. So we're gonna do start 2D sketch. We're gonna start on this face. And we're gonna do tab 0, tab 0, tab enter, and that's gonna be 0.5, enter. And we're gonna do 3D model, and then we're gonna do hole actually, so we can get the angle at the bottom. We're gonna select this, we're gonna move the view. Also, I'm using a 3D mouse, just so y'all know. It's kind of hard not to once you get used to it. I was gonna try and do this, you know what I'm saying, that way people can see how I'm navigating through it, but I'm just gonna use what's more natural. So we're gonna change this to a hole, and this is a countersink, so that should be fine. And one thing we should actually do is check the hex. We'll just do the thing real quick. Anyways, we'll just complete it and then we'll edit it out in a second, because there's some information I don't have that I would like to verify, so I would like to cancel, but instead I'll just do it and just get as close to possible as I can. So termination, that's fine. The direction, that direction is fine. The finished or drill point angle, that's fine. So the one thing that I don't have is this, the chamfer diameter, the countersink diameter, the external whatever diameter of the countersink, and the degrees is gonna be 90 degrees. Is fine. We're just gonna assume we're gonna, if we were to do this by hand, we're gonna assume we're gonna use a spot drill or something. So we're just gonna make that be 90 degrees because that's what the degrees that a spot drill would leave it. Now this is where we need to go back to the drawing real quick. And from the depth is 0.307 from the face to the start of the angle. So that's basically great. That's all we need over here. 0.307 is what we need to put. 0.307. And right here is the diameter. That obviously needs to be changed to 0.5. And the degrees over here, let's see which one is more, what would be the word? Is it steep or which one's more flat? Let's see, 118. I think bigger is gonna be flat, so 135. All right, so we're just gonna leave it at 135 degrees, and everything else should be good. we're not going to go to the advanced properties. I'm not even going to attempt to explain what that means, but I'm just going to go ahead and click OK. And it looks good. And we're going to actually go back, click the plus sign over here, and then double click on sketch. And right here, we're actually going to, what do you call it? Emulate or simulate what the hex is going to look like. So we're going to go to polygon. We're going to go to flat instead of point. We're going to use flat. It's going to be 6-sided polygon. We're going to go to the center and then until it gets green, and then left click and then go all the way out until it locks in. And you see this, I can't even point to it. The little thing that appears, see, there's like a little icon that appears whenever you're at the size, correct size. And I'm going to stick to the middle. That way it sticks to here, because I don't know if you can tell, but it sticks towards the middle. It references the middle, and I'm going to allow it to reference the middle and reference the circle at the same time. That way it references both. And then once it, it locks in or whatever, like I should be locking in, I just click it. You should be good. And now the information that we need is just the diameter big enough to clear this this section right here, the point of the angle. So the minimum diameter that we need is 0.577350. We're just gonna sort of choose a standard dimension. So 0.577. The size below that would be 0.5625. The size above 0.5625 would be 0.578. Yeah, where is it? 0.578. Yeah, because it would be 0.078, right? And then after that is 0.094, right? But 0.05. Wait, hold on. I'm tripping. Hold on. 0.578. Would it be 0.578? Let me do the math. It would be 5/64. 5/64. Yeah, 0.078. Cool. So it would be 0.578. 0.578, but that's cutting it too close. Let's actually see what that would look like. 0.578. See how close that is? And now we're just going to increase it to the next size up in standards, which would be 0.594. 0.594, enter, and we're going to leave like that. We're going to finish, and now that we know it's 0.594, we're going to do it back. We can just click on the minus. That way it goes up. It doesn't bother us or anything. Double click on whole, and then change that to what we discussed, which was 0.594. Right? Looks good. Now what we can do is we can model out the hex, and we're just going to do polygon again. We're going to do to the flat, 6-sided. Going to go to the center till it turns green, left click, and then go all the way up, and we're going to reference the center again right here and reference the circle until it sticks together. That way if you move it, it doesn't even move. See how it's moving, like even a little bit, and it is not moving. There it goes. Just try to get center as possible and click. Should be good. 3D model extrude. And for if it's doing this, where you have to do this, one thing you can do is just select sort of the line until everything highlights. You can just shake it a little bit. You know what I'm saying? Shake it. And click on it. Select the other side. I believe it's 0.307. Select cut, and then 0.307. I said, oh my bad, I'm dyslexic too. 0.307. Okay, I think that's what it was. 0.307. Yeah, 0.307. All right, so let's reference it. I'm show anything I don't need to show that I don't want to show. Let's just view the side view, how it looks like real quick. And I know we need some chamfers and maybe radius or something. I don't know what that is. Wireframe. And we got it sort of. There we go. 1, 2, 3, 4. 1, 2, 3, 4. And then the center line is something that they put there for the thing. So we're not going to worry about the center line because it goes all the way around, not just here. That's why we don't worry about it, because all goes all the way through, but these just stay right here. All right. So we got pretty much mostly everything. Let's actually just add some chamfers and call it a day on it. So let's add this chamfer first. One thing we just got to make sure that it's bigger than the height of the thread. At least that's what I do usually. So we're gonna go back to the paint. Excuse me. We're gonna go back to the paint like we from the ice, and we're gonna do the height is 0.07873. So we're gonna do a chamfer over here that's bigger than 0.07. What is it? My memory is really bad too. 0.078. So we're gonna do 0.094 because that's the next size. Okay, and then for these two, we just gotta make them look sort of like what it is. So this one looks small. This one looks smaller. Let's test this one. The big one. Let's do something like 31 thousandths, 0.031, for basically 1/32. Let's just leave it like that. Might be wrong, might not be wrong. I don't know. We can tell if it's right or wrong sort of by looking at this. But then again, we don't even know what chamfer diameter they used on the thing. So we can't really assess if it's... but I mean, it's close. It's close. It's close. It doesn't matter. Wait, that does not look right. Yeah, it does not look right. But anyways, I'll just leave it like that. I'm not going to get into it. I don't really know how they make it, exactly how they make this. It's probably a trade secret, or maybe it's on YouTube somewhere. So let's just lock in, go back into whatever we're doing. So we assume this one's 31 thousandths. We're just going to assume this one is half of that one, even though it's probably not. So the half of 31 thousandths is 0.016, sort of. That's 1/64. It's 0.015625 or whatever, but it doesn't matter. So now we got sort of something that looks like it, right? Some sort of looks like it. Now what we're missing is basically just the thread, which is 5/8 by 11. So we're gonna draw that, and to draw that, we gotta go to origin. We gotta go to, it's either one of these two planes. It's not this one. It's either one of these two planes that'll work. You can choose either one, doesn't matter. If you choose this one, it's just gonna go to this one, and we go back. If you choose the other one that looks like a line, it's the same thing. It's just the other way. It doesn't matter. You can just reposition it or whatever. So let's actually just leave it like that. Let's do it this way. Let me just get some water real quick. Honestly, the chamfer's probably too big, because also you got to remember the bottom is I think it's the root. I'm not even sure. I think with the bottom, I was like, is it the root or the crest or the something? I don't know. The LaCroix, I don't know. But this bitch at the bottom, it's rounded off or chamfered, or I don't know what it is, but it's usually done that way. I don't know, maybe if it was pointy, it would probably what do you call it, be more susceptible to damage, because you're gonna have an area that's really small, basically the point. Pretty sure that would chip off really easily, I think. I don't know, I'm talking on my ass again. Anyways, I should probably just go back to drawing, to what I know, not to, you know, assuming shit, you know. All right, so the thread length minimum is 1 3/4, so I guess we'll reference that as well. So we're gonna go back over here. We're gonna start a line, and good thing it's already right here. So we're just gonna do tab 0, tab 0, tab enter. We're gonna make a line to the left side. So left side is 90 degrees, so I'm gonna do tab 90. Then I'm gonna do 1.7, 90, tab 1.75, tab enter. And then we're gonna make a line that goes up, tab 90, tab, and then just gonna make it 1 inch. Doesn't really matter. You can make it 3/4. It's just for reference, to be honest. This is basically the length that they want on the part. So we gotta make sure that it goes a little bit beyond that. I think they do that here too. Oh, never mind. Sort of. Anyways, excuse me. So we're gonna do another line. We're gonna start at the middle again. Tab 0, tab 0, tab enter. We're gonna go to the right. We're gonna do 1 inch. Let's just do 1 inch. Doesn't really matter. It doesn't matter at all. It does not matter at all. You can do 0.25. You can do 0.5. We can do 0.375. You can do 0.5. Let's just do 0.5. 0.5, and then you gotta make sure it's all the way straight to the right. So you gotta make sure it's, I think in this instance is 90. So I'm gonna do 90, enter. Then I'm gonna go up, and I gotta make sure it's straight. And I'm not even sure what the dimension that it's supposed to be. So I'm just gonna make a template, is what I call it. So I'm gonna do let's do 0.25, tab, then do 90, enter. And then right here, we would assume that's the pitch diameter. So down we have to go the height of the thread, half the height actually, 0.5. So we're actually just gonna do 0.05. Because that's not correct. That's not correct at all. We're just gonna, like I said, we're just gonna make a template. I don't know what the dimensions are. I gotta go back because my memory is really bad. I'm gonna do tab, and I'm gonna do 0 because it's going back. Tab, and enter. And then I'm gonna make a line towards the left, and I'm gonna make sure it's half of 60 degrees because the thread is 60 degrees, and we're referencing half of it. So we're gonna do 30 degrees. Tab, 30. And for this, we can actually make it go out a lot. It doesn't really matter. We can do 0.25. That's obviously too much, but we're just gonna do enter. Then we're gonna go to the right. And then in this instance, it's 60 degrees. We need to go straight to the right, straight to right. And usually it's 180 or 90 degrees or any variant of that. But in this instance, we're using this angle right here. And this angle is 30 degrees. So to go all the way to the right, we're gonna need 60 degrees. So I'm gonna do 60. Tab, and I'm just gonna make sure it goes to the middle right there. It makes a little purple line for reference. And just once it locks in, just left click it. And then go down, tab, 90. Tab, and then just make sure it touches right here. That's all we need. I just realized I kind of fucked up, but it doesn't really matter. So like I said, just make it meet. Oh, what? Oh, whatever. All right, it doesn't matter. Yeah, like I said, well, to be honest, that has nothing to do with it. But one thing, the next thing, I don't even know if there's like a way you can do it in one go. I might have not really fucked up. Was the next thing was you couldn't really choose the height of the thread with this. It would be kind of, you got to make some measurements, and I'm not gonna do all that shit. We just need the height, which is something that we already have. So we're just gonna assume, we're just gonna go back to right here. Once it turns green, we're gonna click on it because it's a center. There's the pitch diameter. We're gonna click on it. We're gonna go up, and we're gonna go up the same distance that we did when we went down. It's 0.05 down, so we're gonna go 0.05 up. Tab, and then 0 degrees to go straight up. So we're gonna do enter. And then we're gonna go tab 90, and then tab, and then just, it's gonna be free to move, and then just touch it. And I think I didn't give it the degrees, did I? Let me see if it'll do something. Okay, yeah, because I don't think I think you're supposed to put 0 degrees. You're supposed to tell it explicitly 0 tab, you know. And I didn't do that. I just pressed enter, and that's why I was like, I wonder if it'll move. Maybe. Nah, it won't. Okay, cool. That's cool. I was just making sure. All right, now we got the little template. What we can do is mirror this. We do this and this, then mirror line is gonna be this. Apply, and we have finished the template. We got a weird Dorito that's been bitten off somewhere out here at the top. This is the most important part that we need. So we're gonna go back to the little thing. I don't even know. Oh yeah, I put it, the pitch diameter. So it's 0.56025, which is this thing that we have right here. But if you notice something, it's starting from the middle. So it's not a diameter, it's a radius. So it's 0.56025, right? 0.56025, or what was it? 0.56025, right? And then you /2, enter. And we got the pitch diameter good, it's ready, or pitch radius, whatever. Now we need the height, so we go back, and it is 0.07873. So we go back to Inventor, we double click right here, 0.07873 divided by 2/2, enter. Do the same thing over here. Well, you don't really need to be honest. You can, but it doesn't really matter since your insert would technically be about this big, depending on what size insert you're making or whatever. Depending on what insert you have or whatever. I mean, we can make it, doesn't really matter. 0.07873 divided by 2, enter. And it just adjusts it to the proper height. And that's pretty much all we need to make the thread. We go to 3D model, we go to coil, and we choose these two. We go select axis, we choose this axis, and we do the pitch, and it's 1/11. Oops, 11, because it's 11 threads per inch, 1 divided by 11. And the revolutions, that's where we're just gonna play a little bit around with it. We need, like, let's just do 20, see what that looks like. That's not enough, so do 25. That's barely enough, so let's do, I don't know, 27. That's too much. 26 is just enough. I don't know if this works. I've never gotten it to work. Like, flat angle. I don't know. I don't even know. I guess if someone could help me out. I wonder if there's a button to like close it. But since I don't even know, I'm just gonna model it. I'm gonna click OK, and it abruptly ends right there. But I mean, the solution I'm about to give is not that great either. So, but anyways, let's go to it. We're gonna select the face that it left. We're gonna draw on that one, and right here it should already give us a reference where our center is. So we're just gonna go ahead and go to the yellow dot until it turns green. Left click, and then we're gonna go towards the left, and then we're gonna make sure it's straight to the left. So we're gonna do tab 90, tab, then I don't know, 3 inches maybe, and enter. And then we're gonna just draw this out. So I know from experiences from this point, it starts here, you go here, you go here, and then you finish off where you started, right here. And it should all be straight, you know, it should all be good. So I'm gonna do revolve and select axis, cut. Okay, all right, looks it makes it look a little bit better, like I guess from far away. But I mean, I guess from far away you probably couldn't even tell, but I do that on my threads. I like to, I don't know, that's what I do. But anyways, here we have the screw, and one thing we can do is we can look at it from the side view. We're already looking at it like that, and we can look at it again with the, whoops, we can look at it through here. And it basically, I should have just stayed zoomed in. There we go. So that's basically it. We can open up a drawing to, I wonder if it has my drawings. I guess it doesn't matter. I'll just do one real quick. Let's give it the measurements, and let's not even look at it. Cool. All right, so we're gonna save it. I'm just gonna save it as this is what I usually save my things at. I'll put it over here anyways. These are how I save any things that I download. Right here, I just give it the main measurements, and then I give it the description of what it is. Like, for example, this is 0.719 OD by 0.281 ID by 0.063 width. zinc, I think, or plastic, or I don't know, washer, Granger 22UG97. So I guess I'll do that. This is from memory. It's this is how I'm gonna name it: 625-11 NC by 2000L. Maybe it might just be better to put 2KL, or I guess, yeah, 2KL. Excuse me. Just put 2000L. Oh, I already have one. By 26250AL. OAL. What the fuck? OAL. Dash socket head cap screw. And now one thing I'm doing is adding whatever the thing is, whatever it says on here. So this one is alloy steel, because if you don't put like, well, I was putting whenever it's stainless, but I don't know, I guess there's a difference. There's alloy steel, there's regular steel, and I don't know. I'm just gonna put it just in case, like, it's ever needed to know. Alloy steel, there it is, alloy steel. So I'm gonna socket head cap screw. No, let's do AS alloy steel, the socket head cap screw dash Granger dash, and then I'm gonna just copy and paste it. That was the one that I had downloaded too. Paste. Okay, and I just save it. That's usually how I save it. So I'm gonna go to drawing, base, and I'm going to put it this way, and I'm gonna put it as 2 maybe. I wonder if that'll be too big. No, it's good enough. 2, and that should be good. Press OK, and cool. It even shows the inside of it. And I guess let's look over here. Where's the drawing at? Let me see how they, I guess, how did they do it? Because the line goes all the way out. Unless these are like not 3D. Nah, they should be 3D generated. Well, how do they? I don't know. Fuck it. I'll check it out later. But anyways, yeah, there's the little problem. Let's give it the measurements and then we'll look at it. So we should have a 2-inch length. Nice. So now we have a 5/8 head thickness, head length, whatever. So we should have a 2 5/8 overall length. Oh, I got sweat in my eye. It's a little hot inside the shop and I got a long sleeve shirt on. It's just because I don't like fucking mosquitoes, man. Them motherfuckers just like, they creep up, and then by the time you notice, you're like, by the time you like try to sweep him off, he already done got some of your blood, and he's already gave you some of his whatever the fuck liquids, disease they give you, I don't know. Anyways, let's see. Then we got the 0.938 diameter head. And then we got the, I'm guessing from here to here is 0.5. Oh, no, I guess not. Anyways, 0.307 should be the distance. Yep, 0.307. I guess I'll see if I can add the other view. Probably gotta make this a little bit smaller. There we go. So this radius, that's what it's supposed to be, a radius, so it's supposed to be 0.5, so that's correct. 0.938 is the diameter, so yeah, that's correct. What else? I don't know how I can check the pitch. Just like that. .0909. Nice. I've never checked the pitch like that, to be honest. I can't believe that worked That is awesome. Nice. Very proud of myself right there. I think that's it. Diameter. So the hex key width is supposed to be 0.5 as well. So there we go. But the overall thing is big as fuck, so that's not. There we go. Yeah, so that's pretty much it for at least for this one, I think. I guess on the other one, what we can do is I guess model a hex or something on for one of the other ones for the 7/8 or some shit. We'll see in a minute what I do, what I feel like doing. What time is it? It's already, it's 4:23. I done missed the time and damn. It's kind of sad. Makes you wanna. Alright, so now that we're done with this one, I guess let's model the nut for this. Let's find the nut that we can model for it. Let's go to fasteners, nuts. Let's do flange nut, fuck it. I wonder if they even have drawings. Oh, we'll see. That's the only problem. It might not have drawings. Nice, it does. 5/8 by 11 nut. Okay. Okay. Cool. So one thing we can do about this, we can Google the tap drill chart. That's one way to do it. And for 5/8 by 11, off the top of my head, what is it? It's 531, right? I think it's 531. We'll just do it. We'll just calculate everything. So we got the minor diameters between 527 and 546. So yeah, 531 is definitely inside of it. I mean, it's not the middle, but it's definitely inside of it. It's bigger than the minimum and it's smaller than the maximum. So but I'm pretty sure for, you know, for nuts and stuff and taps and stuff, there's like a certain percentage that they hit. So you could technically hit lower or whatever, lower percentage. I believe this is like a 75% thread or something like that. I don't even know. So 531 should be good. I'm just gonna go with 531. We can calculate the middle. I mean, it doesn't really matter. 0.527 minus 0.546. You get 19 thousandths divided by 2. And since the number is negative, we're just gonna minus it from the minimum. 0.527. We got 0.5365. That's more than 0.527 and less than 0.54. So it should be good. That's the middle. So the middle is technically supposed to be 0.531. I mean 0.531. 0.536, 0.537, but there's no drill for that unless you go metric probably. You'll probably find something metric. But more than likely you're just going to want to use whatever, like, and the easiest thing to grab for someone in the US is probably a spade drill. At least for me, it's a spade drill here in Texas. Some people might be like, I'll just grab a drill. I just grab a spade drill and grab the insert, the spade insert with what is it, what would this be, 1732, right? 17/32, 531. So 0.53125. okay, so actually let's write all that shit down. Let's go to the history. Is this the history? Okay, excuse me. So let's write everything down real quick. From 0.53. Oh, because I was thinking, let's just skip over writing this shit down. Let's just keep going to save time. But it's like, you might as well be consistent on something. You know what I mean? So let's just write down the notes. So the minor diameter, let's go over here. Let's go int thread. Okay. Min, oops, wrong button. Min dot d dot, or just d. Doesn't matter. This one's just put d. All right, d, and then it's gonna be dot 5636, right? 5635 or something like that. 5. Oh no, not 56. 5. Dyslexic again. 5365.5365.5365.5365. 5365. And I know off the bat, like, well, I guess this should be a note for somewhere in the middle. I'll put it, but I know for me, I usually what I write down is the middle of the thing. So I know for a fact, you know, this is the middle of it. But that's why I'm also gonna write down the spade. .531. And then I'm gonna put parentheses 17/32. Okay. All right. And now we need the pitch diameter, right? Pitch diameter. Point. All right. Let's do right here. So the pitch diameter 0.5660, 5767. Let's do the math. 0.5660 minus 0.5767. What the fuck? Right, okay. Divided by 2, enter. Minus the minimum, I believe, 0.566. So it should be 0.571, and it's less than 0.576, so it should be good. 0.57135, 0.57135, 0.57135. All right, so it's our pitch diameter. So I think, oh, we need the height. No, with the height, we already got it. I think that's it. That's all we need. And I was gonna be like, oh, well, I was gonna check. I was like, I wonder what the difference is between these two. And I was like, oh wait, I wrote it down. Nice. I don't even have to do the math again. So that's nice. Let's see. Yeah, that's pretty much it that I wrote down here. So I'm just gonna leave it like that. And now we're gonna model it. So we're gonna go back. We don't need this. We don't need this. There we go. This is what we need. So it doesn't give us the thingy. It doesn't matter. It give us the height. We'll just guess it. It doesn't matter. I guess for this, it'll be handy to do the revolving. So I guess we'll revolve it this way. So we got 0.813. I wonder what the diameter is. What would the height? Oh, the biggest diameter is this. The hex is at least this. Okay, I see. Okay. All right. So 1.375 is the biggest diameter. We'll start with that. Okay. Actually, I'll just put them side by side. Does that? Okay. Or like, what is that? But that's not really relevant. We already know it's a 5/8 by 11. So we're gonna do new. Standard IPT, start 2D sketch, XY plane, and we're gonna start with a line. Actually, we're gonna, like I said, revolve this. So I mean, you can draw this however you want. You can draw a circle, then extrude it, and then draw the whatever the ID is at the end and cut that, or you can be smart about it and extrude also the cutout of the ID of the thread. But in this instance, I'm just gonna revolve everything. So we got 1.375 diameter by 0.188 thickness. So I'm gonna start in the middle, go up, go this way, and I guess go down just to finish off the reference. Then I'll just guess this thickness and the, what do you call it, the depth, just by looking at it. Oh, I'm not gonna download, I'm just gonna look at it. Okay, cool. So it's at least it at least has to be round, and it's not completely flush to the face of the circle of the round surface, but so I'm gonna make it a little bit smaller. I'll probably give it some kind of standard measurement, since this is also standard measurement, 1.063 and 1.188, 0.813. These are all standard measurements, so I'll just use standard measurements to guess this width and depth, but it doesn't really matter, but just to make it look alike. So line and then points. I guess we can do a reference. Well, we'll do the reference real quick for the hex. Wait, it's not, no, we don't need a reference. 1.06. No, we do, because the hex needs to be cut at the end. We do need a reference. Okay, so we will make a reference real quick. So we're gonna do a line. We're gonna do tab 0, tab 0, tab enter, and like I said, this is just gonna be a reference. So we're just gonna go all the way to the left. We're gonna make, like, I don't know, like a 3-inch line. Yeah, 3 inch. Actually, 2 inches. Well, nah, let's just 3 inch. 3 tab 180 tab enter. And over here, we're just gonna draw the reference to see how big we need to draw the hex thing, the diameter for the hex. So we're gonna do a circle, and we're gonna do right here till it turns green. Just left click, then do 1.063. Then we're gonna do the polygon, 6-sided polygon to the flat. Then we're gonna do the center. Left click on the center, and then left click once it make sure it also references the center like this way, you know, that way. Make sure the purple dotted line also references once you go all the way up and see this reference. Once the icon shows up and the purple dotted line shows up, you should be good to go. So I'm gonna left click, then escape, then circle again on the center of it, and then see what the minimum distance is. 1.227. So it has to be less than 1.375, but way more than 1.227. Let's give it a random, not random measurement, a regular measurement. Oh, 1.22. Okay, 1.22. So it can just be 1.25, right? It's about 30, not 30, like 23 thousandths above it. So let's do 1.25. See how that looks like. There we go. It looks good enough. So we're gonna need to make this area 1.25 diameter. So that's something we needed to do the math of, sort of. So now that we have that, this should be no problem to model the rest of it. So let's start with the line. Tab 0, tab 0, tab enter. And we're like, technically, just for reference, we're right here is where I'm imagining it. We're gonna go up, left, and down just to finish the line. Or also, once we hit down, we're gonna go right. So we're gonna make a rectangle just to do this little area. So the diameter for this is 1.375. So we're gonna do 1.375/2 tab, and we have to make sure it goes up, straight up, 90, enter. Then we're gonna do the left, and it's looks like it's 85 degrees. So I'm gonna do tab 90, tab, and it locks in. Even if I go up and down, it locks in. It doesn't go up and down, it just goes left and right. And the distance is 0.188. Enter. And now I go down, tab 90, tab, and then just it hits the middle, and it's 0.6875. I can be specific, I can specify it. 0.6875, tab 90, tab. I was gonna do tab, and I just enter. And then I'll do tab 90. I was gonna do that to close it, but with the reference kind of already closed it, so we don't really need it, but we'll do it anyways. Then we'll just touch it, or you can do 0.188, enter. And there we go. We have this drawn out so far. Now we need to draw this area out, and then from that we will be able to draw this out, sort of. So Excuse me. Gonna go to line, gonna go over here where the other one ended. Actually, no, not gonna go over here. Gonna go to the center, so of the whole model. So I'm gonna do, or the whole, what is it? The origin. So I'm gonna do tab 0, tab 0, tab enter. I'm gonna do left, so I'm gonna do 0.813 tab, and then it's 179 to where I'm at right now. So I'm gonna assume it's 180. Enter. Go up, and then we had mentioned that it was 1.25 divided by 2, tab 90, tab enter, tab 90, tab, and it should lock in all the way to the right, and you can just touch it if you want, or you can give it a dimension. It's 0.625, tab 90, tab enter, and we basically have this. Let me see. I guess I can probably. I wonder if I can do another screenshot. New. Actually, new. Edit in Paint. All right. All right. Basically what we draw now, just in case it's not clear, I guess I might as well make it clear. We drew a line from here. Should I just make it red? Draw a line from here to here. Then we drew a line from here to here. It's not straight, but it doesn't matter. Then we drew a line from here to here. Then we drew a line from here to here. Then after that, we started here in the origin. We drew a line all the way over here. We drew a line from this way to here. Then this way to this way. So what we're missing from the red lines is, apart from the chamfers, well, I guess chamfer. Well, actually, yeah, chamfers. You know, it needs chamfer right here, chamfer right here. Is we're missing the. Let me make these different color just so. Oh, the chamfer. Then we got orange, yellow. We got yellow. Yellow thread chamfers, inside chamfers, whatever. And then we are missing, I guess gray. Gray's probably not gonna help. Pink. This is just pink. I think that's pink, right? Yeah, that's pink. We're missing this. Kirby pink. We're missing Kirby pink. We're missing the Kirby area. This is the Kirby area. So, I'm gonna zoom in. Just look at over here. Let's see if I can zoom out. There we go. That's what we got so far. To be honest, we could just not really give a shit what measurement it is. We could just draw it out like this. And it wouldn't matter. I guess we can just make it something like that we would probably use a good size. I don't know, like something like an 1/8, 0.125, and that's probably too much, to be honest. It's probably too much, but we'll just make it 1/8. And then the hex, the flat, is 1.063. 1.063. So I'm gonna do tab 90 and go all the way down just so I can leave that line there for reference later. Right. And I'm gonna do what was it, 1.063? Yeah, I think 1.063. 1.063 divided by 2, tab 9, tab enter, tab 90, tab, and just make it meet. So that's the minimum. And if we do that, we're gonna need to make it a little bit bigger, because if you look over here, technically it goes beyond it, beyond the flat down. So from here to here, you have a little bit of space. So we're gonna get a size right quick. We're just gonna see what it is. 0.0935. That makes sense. 0.094. That would be the measurement for I forgot what the size is. What is it? 7/64 maybe? Or is it 3/32? 3/32. So this is the size for 3/32, sort of. We can just go the size next up. After 0.094, you get 0.109, I believe. So we're just gonna do 0.109, but we're not gonna use it. We're just gonna reference it. We're just gonna use it for references right now. Tab 90, tab. We'll revolve it later. We'll come back to it. I'll show you why. Sort of. It might make sense. But we're gonna go ahead and actually no, we're not ready to revolve. We need to get the inside diameter and stuff. Okay. So the next thing we need is the inside diameter, which is 0.531. So gonna make this big. And we're gonna start in the center, tab 0, tab 0, tab enter. We're gonna go up, 0.531 divided by 2, tab 90, tab enter, tab 90, tab, and let's just make it meet, and it looks good. And we can just make the angles based on the, like I said, I usually just go like 1/64 above whatever the height thread is. So it's 0.078. So I think I went 0.094, I believe, on the other ones. I'm just going to go ahead and 0.094. I'm not even going to check. So we're going to do 0.094, 0.094, tab 90, tab enter. We're going to do 45 degrees, tab 45. All right, just make it touch. And do the same thing over here. So I'm going to start right here, 0.094, tab 9, tab enter. Then do 45, tab 45. Alright, just make it touch. And we can actually change the degrees if we wanted to. We can make it 30 degrees, and we can probably go over that in a bit. Oh, 30 degrees. And I can't remember. Someone told me that it was recommended that you just go ahead and give it the 30 degrees to the chamfer. But I don't know. Sometimes it makes it look, I don't know, a little weird. But I don't know, I just go with the standard 45 degree. Maybe I'm wrong. Maybe he was right telling me that go ahead and use 30 degrees or whatever angle. Like, for example, if I was doing an ACME thread, he would probably say to use whatever the degrees on the ACME thread is, just so it could, I don't know, go in at the same degrees. I don't know. But anyways, I'm just going to do 45 degrees. But I guess we can show it in a minute. Actually, might as well just do 30 degrees on one side, 40 degrees on the other, 45 degrees, I mean, regular 45 on the other. And extract, we're getting 30 on the first one. And we'll just see the difference on how it looks like once it's modeled. Because we're basically simulating the tool. Like when we coil it, we're basically simulating the tool going. We're basically making a small program cutting the tool. But anyways, I think it's ready to model. This is too big, to be honest. Looks too wide, I think. I'm thinking maybe it would be 0.094. Maybe it would be 0.063. But we'll just leave it. Fuck it. It don't matter. Something else that's missing. I believe it has an angle right here as well, right? Has an angle here. And probably an angle here and an angle here. Alright, let's, I guess, figure out these. Should I figure out the angle or just give it a random angle? Because I know on hex you kind of give it, you have to give it a certain angle, but we can probably come back to it if we need to. Alright, so let's actually just revolve it. Let's do this, and we're gonna ignore this as well, of course. Yeah, looks good. Select axis, this, okay. And there we go. We have what the fuck? Oh. Whoops. There we go. Yeah, that was dumb. Okay. So pretty much got it. We'll go back to the things that we need to go back to in a minute, but let's model the hex real quick. We're gonna do 2D model. Start 2D sketch on this space. We're going to do, what diameter was it? Tab 0, tab 0, tab enter. It's 1.063, I believe. 1.063. And 3D model. Actually, no, not 3D model. I forgot. Select more than polygon. Select the middle, and then I forgot, it's gonna be towards the flat. And select, make sure you use the reference to center and the diameter that you just made, the circle that you just made. Right there should be good. And I should probably create another circle. Go to the center and a circle all the way out. It's like maybe 2 inches. It just has to go all the way out just to cut it. So 3D model, extrude this, cut, and actually we're gonna use a 2 into this space. And okay, there we go. So like I said, we ignored what we did, the extra little bit that we gave it, and we left it right at the exact measurement. And see how there's no room or nothing at all. But if we go over here, there's a little bit of room. That might just be a mistake on the view, but on the rendering, I mean. But I'm gonna go back to the revolution. I'm gonna go to the sketch. Where is it? Is this? And I'm gonna leave the control button pressed while I left click onto this, so it deselects it. Now okay, press OK, and now you got a little bit of thing right there. Looks a little bit more accurate, a little bit. Now the last things that we need to do is the angle, and I forgot, we could have just done it over here because the diameter is 1.25 for the hex. Right, so that's the smallest diameter it needs technically, right? So I'm gonna double click on the first revolution sketch. Is that why I had this? That's why I had fucking done all this shit. Yeah, I didn't even use it. So I'm gonna go over here. I'm gonna start a line right there, and I'm gonna do 1.25 divided by 2, tab 9, tab enter. Oh. It's not 1.25. Oh shit. Okay, cool. So it's 1.25 divided by 2. 1.063 divided by 2. Fuck. Alright, whatever. Start line here again. 1.063 divided by 2, tab 9, tab enter. Tab 90, tab. Oh. I already had a reference right here. So cool. Let's just see how much difference it is from here to here. I was gonna say let's give it a certain diameter, but I mean, yeah, I guess, yeah, just give it a certain diameter. So I'm gonna choose this line again right here. It's 1.25 or 1.063, so I can just give it 1 inch. So 0.5, tab 9, tab enter. Then I'm gonna do tab, I don't know, 150 degrees. Basically a 30-degree chamfer. Finish. Revolution. Gonna deselect this and deselect this with the control button pressed while I left click, and there we go. And that's how it looks. The last thing we need are probably these two chamfers. I don't even know if it has chamfers on the thing. It doesn't look like it is. Hold on. I guess maybe looks like a radius. So I'll give it a radius. 0.016, something really small. That's probably not right, but whatever. Okay. And we can only assume if we're doing it that it's gonna have a radius on the insert. So I'm gonna use some radius that I know that it would be, and the radius of the insert would be 0.008 on the corner radius. So that's technically to me what it would look like, I guess, if I would do it. And now we're just missing the threads, so we're just gonna save it. I like to save it just so make sure, like sometimes beforehand, before I'm done, just to make sure, like in case the light goes out or the computer crashes. Okay, so let me see what it is. I don't even know what it is. 13/16 hex height. 1/16 hex width. Okay, 13/16. Okay. This is a flange dash nut dash stranger. And what is the material? I guess I should probably specify the material. Steel. Material grade class 12014. Okay, 12014. Wait, did I delete the fucking 4? Yep, deleted the 4. By 8130 overall height. This should be it. That's all we need for it. Save it. Then we need a thread. So let's go start 2D sketch, origin, and then select one of these two. It doesn't really matter which one it is. Select this one and do line, tab 0, tab 0, tab enter. Then I'm gonna make it to the left this time, or I don't even know which side I made it, the other one. So I'm gonna do 0.5 tab and then, I don't know, 0 degrees, tab enter. Then I'm gonna just sort of draw again the little template. 0.25 tab 9 tab enter. This time I'm gonna go up 0.05 tab 18 tab enter. Then I'm gonna start it from this way. I think this is the right way. Tab 30 tab, and then I don't know, 0.25 enter, and then tab 60. All right, cool. Then what I'm gonna do is from here it's gonna be 0.050 down, 0.05 tab 9 tab enter, tab 90 tab, and then all the way till it touches, and that should be the correct thing. Now I mirror this and this, mirror line this, apply. We should be ready to get the information. So the pitch diameter is I don't think we need this anymore. I just wanted to explain what the things that we need. I'll say we need 0.57135, 0.57135, 0.57135 divided by 2/2, enter. And the height 07873, 0.07873 divided by 2. And double click this one, 0.07873 divided by 2. We should be good to go right here, I think. So we're gonna do coil, select these two profiles and select the axis over here. 1-11, cut, okay, and it goes all the way through. So I'm just gonna go ahead and put okay. And we should be good to go. Wireframe. There we go. And this one we don't have to worry about, since it doesn't stop anywhere. We don't have to worry about finishing it or anything. So it's pretty much good to go. Oh yeah, this is what I was talking about. Leave like a complete notch, since over here it starts it. Like it starts with the pico, with the spike. And then it gradually moves into a thread. Over here it just like, I don't know, slams in. Well, it doesn't, I don't know. I've done both of these, like tried both of them. I mean, and things that they didn't specify. Like I'll make this one 30 degrees. This one, well, not like differentiating the parts. The parts were all done the same. I mean, like I'd be like, oh, in this thread I'll try this 30 degrees, see how it looks. Whenever it didn't specify. I don't know. But now I just do 45 degrees. Can't remember why. I think there was a problem with doing it this way. I can't remember. Anyways, yep, that's pretty much doing the nut and the thread, and we can actually check these, I believe. So I'm gonna save it again, and we're gonna do a new standard.iam place, and we're gonna do these two here. Right click, and I'm gonna ground it. That's what I like to do whenever I begin my my models, or I mean my assemblies. I like to ground the first item that I put in, just because I don't know, I think it moves this, and then whenever you put top, instead of it looking like this looks clean or whatever, it would be like this, or like this, or like this, or like this. I don't know. Anyways, let's go to view, visual style, wireframe, just so we can check the threads. This is the one that we can turn, so we're gonna turn it until it looks to match and be halfway. There we go, it looks halfway. So yeah, you see the blue is the one that's inside, the gray is on the outside, so looks pretty good. We could add some radiuses to it. I believe they have some radiuses at the bottom. Well, right now that it's like good right there and looks good, I'm gonna ground it. That way it doesn't move whenever I change the model. I'm gonna change it as assembly one. I mean, save it as assembly one. Don't really care. Let's see, where were we? Okay, right here. This one, radius, and we can, I guess, go to the book again. I think the book tells you what it is. Let's go back. Flanks, oh no, 0.25p. R equals 0.108p. Where's that? So pitch is 0.07873, right? Alright. 1/11, enter. Okay. I think maybe I did something wrong. well, I'll look back into it. 0.0909 times 0.108, 0.0098. So we can just make it half of 64th, so 0.008, or we can just do 0.0098. Okay, I guess I'm thinking that's good. Looks good. Let's save this. Okay, nice. So we have the radius right here. We can actually add a radius to the top one as well. I don't know if it's gonna be the same. I guess I'll check. This is access of external thread. There was one. Where's the internal thread? There was one where it was an internal thread. I thought I saw someone that said internal. Never mind. I think actually I'll leave it at this for this video. I'll make another one, I guess, tomorrow on the what do you call it? The what do you call them? The threads, the ACME threads. So I had forgotten that I was gonna show some pictures at the end of the video. Right here's the screw rod, and here's a nut. It's a 1 3/16-5 ACME nut. It was purchased from McMaster Car just so I can check the thread. Or well, not me, the homie who made it. Shout out to Neto again. He made this. He made actually most of these parts. Actually, no, I think he made all of them, all of the parts. You know, except of course, like I said, we bought this, the master thing, the master car part. What else? I mean, it's not finished. I gotta do some. I gotta finish some stuff on it. But it's pretty much mostly done. I just gotta do at the end over here where the 1 inch by 8 NC thread is. I have to add the taper where the precision seal washer goes. So right here you have a close-up picture of the brush seal that I'm gonna try to see if it'll work. We'll see if it'll work. If not, I guess I'll change it, or I don't know. I'm pretty sure it'll work. I mean, it's pretty locked in or whatever to this. It stays like, I don't know, it got a good amount of pressure in my opinion, but what do I know? Right there, and right here is where I have to make the little taper, so the precision seal washer can mate there and stay concentric. And right here I think, I don't know if there exists, maybe making not making, fuck that, I'm not gonna make one. Maybe a bearing, oh, maybe what do you call it, a taper roller, but I don't know. But actually it needs to be low profile. That's the problem. I wanted to see if maybe find a low profile bearing that I could put here, just so over here it's also concentric, just stays concentric. But I don't know, maybe the what do you call it, the thrust bearing will keep it concentric. I don't know, I'm not really, you know, too versed on it. But anyways, see, that's the precision seal washer. I also need to make the taper on here. Probably do with a ball end mill, I don't know. This is the other side. This is the hex for it, the M6x1 hex. It's 30 millimeters long. This is the rear retainer nut, rear retainer nut, rear retainer washer nut, and they're blanks because I gotta drill them out, and I gotta drill tap these, and I gotta drill and mill out these, well, this one. And this one is ready. This one's already done. It has the hole and thread, and I think that's pretty much it. That's all I had to show right now. So that's pretty much it. But yeah. All right. Thanks for watching. Later.